Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the parent chain ring. The structure shows a 6-membered carbocyclic, cyclohexane, ring, so the parent name is cyclohexane. Step 2. Identify the principal characteristic group. There are 2 oxygen-containing groups present, a carboxylic acid, CO2H, and a ketone, C is equal to O, within the ring. According to IUPAC priority rules, carboxylic acid has higher seniority than ketone, so CO2H is the principal characteristic group and receives the suffix carboxylic acid. Because the CO carbon is exocyclic, attached to the ring carbon, the suffix used is carboxylic acid appended to cyclohexane, giving cyclohexane 1 carboxylic acid with C1 being the ring carbon bearing CO. Step 3. Number the ring. The carbon bearing the CO substituent is C1. Locant 1 is implied assigned to give the ketone the lowest possible locant. The adjacent carbon in the ring that bears the ketone is equal to O is C2. Step 4. Name the ketone as a prefix. Since the carboxylic acid is the principal characteristic group, the ring carbonyl, ketone, is expressed as the prefix OXO at position 2. Step 5. Assemble the name. Parent ring is equal to cyclohexane, principal group suffix is equal to carboxylic acid at C1, prefix for ring ketone is equal to 2OXO. Full name, 2-oxocyclohexane, 1-carboxylic acid. There are no other options to eliminate in this naming question. The systematic IUPAC name uniquely and unambiguously describes the structure shown. Therefore, the correct answer is 2-oxocyclohexane, 1-carboxylic acid. The correct answer is shown on screen.